Well, welcome everybody to our Thursday evening Zoom presentations, our solar stories, and other clean energy topics. Thanks for coming. And I'd also like to thank our sponsors, the State Department of Environment, Great Lakes, and Energy, EGLE, Homeland Solar, Harvest Solar, Sri Energy, and Sumter Solar. And tonight, I think we have a really interesting topic. Jenna Knudtson, who's a PhD candidate in electrical engineering at the University of Michigan, is going to talk to us about research she's been doing related to electric vehicles and virtual power plants. And I know from previous sessions we've had on these topics, there's a lot of interest. So please mute yourself until Jenna has kind of gone through her presentation. So, Jenna, go ahead.
Hey, nice to meet you. I'm Jenna. I'm really excited to talk to you today. Um, yeah, and let me know what questions you have. And yeah, I thought I'd get started sharing my screen. All right, is it full screen?
It looks good.
Okay, cool. Yeah, so I'll be talking about the research that we're doing in aggregating the charging and control of a bunch of electric vehicles. As John said, I'm at the University of Michigan. I'm in Johanna Matthews lab. Um, and a little bit more about myself. So, yeah, I'm about halfway through my PhD. I've got a couple years to go. In the past, I've interned at Sandia National Labs, National Lab of the Rockies, or NML, Lincoln Electric System in Nebraska, which is all public power. Um, And I'm definitely thinking of going back to the national labs after I graduate, but I'm kind of open to anything. In the past, I've designed and built solar powered lighting systems, so I'm kind of familiar with like at-home solar, like off-the-grid solar, that type of thing. And then I play Ultimate Frisbee when I'm not doing research, and I have a lot of fun with that. Um, But to try to summarize my research in one slide, basically we're looking at flexible electric loads for power grid resilience and decarbonization. So what do we mean by flexibility exactly? Basically, you have the ability to shift your power consumption or your production to a different place. So the examples that I've researched include EV charging, HVAC in buildings like commercial buildings or even residential buildings. The water system is actually flexible and when it can run its pumps and other loads, and data centers, of course. Um, so load flexibility helps to make the grid more resilient because it can help smooth out the demand curve that they're seeing on the right. Um, if you have a smoother demand curve, you don't have to rely on as much capacity. There's less drain on the grid in general. Flexibility and load can also help the grid restart after outages, because if you have like microgridding going on and you only have like rooftop solar locally or like a battery locally, if you have flexibility in load, you can just start by powering a couple small loads, get some grid stability going, and then connect to other microgrids as you expand out. That's some pretty interesting research there. And then flexible loads can also help with decarbonization. So, of course, moving from gas-powered vehicles to EVs is good, but lots of EVs coming onto the grid can drain that load curve. But if you control EVs, you can control them to charge with renewables. So if the solar is producing a lot, you can have the EV charge during that time and then withhold charging when solar isn't producing, and things like that. Um, Another thing is that those kind of represent like a renewable resource alternative to coal and natural gas. And they actually have an advantage over coal or natural gas because they can respond more quickly to fluctuations than traditional generation. But what we're going to focus on today is EVs going from a burden to a service. So first of all, why might they be considered a burden? Like more load, meaning more strain on the grid, but what does that really mean? When we talk about services, what kind of services could they potentially provide? And then how does that actually work within the regulatory and market frameworks that we exist in today? And then how does our research actually make this possible? What challenges are we trying to overcome still? So hopefully you guys are maybe familiar with the idea of a distributed energy resource. We call them DERs. And basically, we're referring to any source of energy or demand flexibility where the connection point is the distribution system. So that's like the local grid system in Ann Arbor or wherever you live, where you see the wooden pole top transformers and all of that stuff. So that's the distribution system. And then examples of DERs would be like your rooftop solar and other flexible loads. However, utilities like DTE or consumers are placing limits on how much DEI can be in one part of the system at one time. So why is that? The reason is that they can cause issues on the grid if they're not managed correctly. Um, so there are two kind of indicators of instability in the grid. There's voltage and frequency. So if the load becomes greater than the generation at any point, then the frequency will dip. So we want it in like the 60 hertz range, but it'll dip if the load is too high, the generation is too low. Opposite, if the generation too high and the load is too low, the frequency will rise. Um, Similar thing with voltage. If there's too much load on the grid, the voltage will dip. If there's not enough load or the too much generation, the voltage will rise. And these type of voltage issues, the power quality issues, can disrupt sensitive loads. And they can even like trip off really big loads. That's what happened in PJM last week. I don't know if you heard, but this really big data center load tripped off the grid really quickly due to some sort of voltage issue caused by a not transformer, transmission line outage. Um, Another thing is just the grid, like the pole top transformers and the lines that carry electricity, they're rated to carry a certain amount of current. And if they carry too much current, they can overheat or wear down. They can even catch on fire. So if you are adding more load or if you're adding power to the grid going the wrong way, then this higher current can cause the transformers to heat up. Another thing that's like more on the side of like um, solar panels and like actual power production is that the way that the distribution grid has been designed up until now is it expects power to only flow one way, and that's how we designed our protection system. So the protection system, like the faults and the breakers and trip off, don't work with this new flow of power. So alternative protection designs are the subject of current research. However, because of their flexibility, DERs and aggregations of DERs can provide services to the grid. So these are examples of that. One, of course, is like flattening, smoothing out that load curve, or something called demand response, where you agree to lower your load when you're called upon. Another is a virtual power plant, where you agree to increase your load or decrease your load from a baseline. Frequency voltage regulation, basically responding to fluctuations in load in order to keep frequency around 60 hertz or keep voltage within the desired limit. So how does that actually work? Like, what is the framework for providing these services? So in a lot of the US, we have a deregulated energy market that's run by the different ISOs. In Michigan, we have MISO. PJI just talked about with their data centers over here. CAISO, ERCOT, all of these. And basically, because of the research around aggregations of DERs and what they can provide to the grid, FERC, the Federal Energy Regulatory Commission, implemented this order that these market operators, the ISOs operate the energy market in their area, they all have to find a way to allow DER aggregators to bid into the electricity market. Now, as I said, like ISOs operate the wholesale energy market and that they procure energy from generators and then sell it to consumers who then resell it to us at a different rate. But MISO sets like the wholesale, controls the wholesale market and prices and all of that. Into this equation, essentially what they're gonna do, they're gonna aggregate the power and energy availability of a bunch of different EVs or flexible load. They're going to bid that into the market just like any other generator. And then MISO is going to optimize and co-optimize all the resources for least cost operation, and then communicate the expected energy back to the generator, back to the aggregator, who then has to control the fleet of EVs according to the schedule. And I just want to emphasize that participating in the market and providing service is different from like time of use rate or like special tariffs that DTE or consumers might offer. That's just like to encourage utility customers to try to charge or like move their load to a different time, but it's not the same thing as bidding into the market. So the project that I'm working on now, funded by the EV Center at the University of Michigan, and we're working with the Center for Automotive Research, members of the electric vehicle industry, and local utilities to address the challenge of aggregating and coordinating many EVs to participate in the market and provide services. So there's four key steps to making this happen. The first step is to model the flexibility of the entire fleet. That is like upper and lower power and energy bounds. The second step is finding out how to bid into the market and optimize that. The third step is figuring out how to control all of the EVs according to the signals and the schedule that we get from myself. And then the fourth part, which is kind of the main contribution of this work, is to make sure that all of these um, are aware of the distribution network. And we'll talk more about what that means later. So to model EV flexibility, we usually use a kind of simple model where we say that the data charge in the next time step is going to depend on the data charge in the last time step, plus how much we decided to charge. Um, and then also charging power have to stay within some minimum and maximum value. L2 charger, like the maximum is like 10 kilowatts or something like that. And then we want to make sure that the customers who are participating in this program get their state of charge to where they need to be before they leave the charger and go off into the world. So that constraint, this final constraint, allows us to do that and ensure that. So that's an individual model of an EV. Then aggregate models capture the power and energy constraints of the entire fleet. So the exact aggregation is this mathematical concept called a Minkowski sum, but computing the Minkowski sum could literally take forever. Something called an NP-hard problem. People have proven that it could literally take forever to actually calculate this. So there have been different models that have been developed to overcome this, and one of them is like inner approximation, where the feasibility is like not capturing the entire flexibility space of the whole fleet, but it's going to be somewhere inside of it. Um, and this is kind of a good approximation of that, where you have a lower power bound and an upper power bound, lower energy bound, upper energy bound, as you go on over time. So the reason why we want to do aggregation and not model each individual EV is that aggregation enables simplicity and scalability and privacy. But some of the challenges are like, how do they scale? Can we use it for hundreds, thousands of EVs? And how well do they perform under uncertainty? And then how do we account for uncertainty in driver behavior and also the market prices and signals, which are very random? Um, and then finally, how do we integrate it into our bidding model? So the bidding model takes in the aggregate flexibility model of the fleet of EVs needed to give to myself. So some challenges with that: what markets and services do we want to participate in? Are we most suited for just wholesale energy? Should we provide voltage regulation, frequency regulation, all of it somehow? Um, how do we create a supply curve based on our charging needs and flexibility? This is how generators fit into the market. They basically have a table of like, okay, at this price, I'll provide this amount of power. At this price, I'll provide this amount of power, etc., etc. So how do we do that with EVs? And then the final thing is that all generators have constraints. So like minimax power generation, startup shutdown constraints. So what constraints do we need to communicate to MISO, and how do we communicate those? And then the third step of the project is focused on the control aspect. Um, we need to be able to control the EVs, because if we don't follow the schedule, we will get penalties. Um, the different challenges with that is like which control strategies are most effective. There's several different ones that we're looking at now. And then also how do we ensure privacy? Um, if you look at the control signals and like the action, you might be able to discern different things about the times and the place where different EVs are. So how do we ensure that someone isn't able to do that? Then the final part, so distribution network awareness. We talked about how we can stress out the distribution grid by current into it or taking too much current out of it, messing up the voltages. So how do we incorporate like a simplified model of the grid or like data from the grid to make sure that our bidding model, our flexibility model, our control algorithm aren't are taking that into account? And then I wanted to end with talking about what can GRIVA do with your position. Um, so continue advocating for GRIVA-friendly policies at the state and federal level. One thing that I don't know what the answer is for right now, but I do know that proprietary EV charging software does make it harder for us to research and implement different communication and control strategies with EVs. So something we might want to advocate for, are like copyleft or like right to repair type of initiative. Um, Another thing is to support vehicle to grid technology. So we'll have even more flexibility when bidding into the market and we can make more profit and offer more services. Um, and then also like participate in and bolster different demand response and managed charging programs in your area so that utilities know that customers are interested in this sort of thing. In my classes, we're basically taught that demand is inelastic, like for electricity. Like people are just gonna use however much load they want to use, no matter what the price is. So that's changing a little bit, but hopefully we can continue to show that we're responsive to price and we're interested in helping out the grid. And then another thing is just continue educating the public. There's a lot of misinformation going around. So first of all, if you do participate in DER aggregation, there are different aggregations like startup companies, so this is starting to happen. It can help you earn more money and also save on cost, especially with how much it costs to buy an EV, especially a new EV. Another thing, you probably all know this, but EVs and solar panels don't have to be a burden to the grid. They're very responsive, they're very flexible. We can make this work. Um, Another thing is to flatten that load curve. That's cheaper than having to build out more generation. With all this new load coming onto the grid, um, they're like unretiring coal plants and like trying to build up all this more generation. But if we're just a little bit more flexible with our load, that's cheaper than have for us as customers too, than having to build out more generation. Um, and then finally, I saw this post from the U.S. Department of Energy, and I had to include it because it's very funny to me. But all generators, including fossil fuel, have constraints, like I said. So saying the U.S. Department of Energy wanted to comment on how during a peak demand hours during the heat wave, wind wasn't available and solar wasn't available. And it said by sunset, 99% of solar power failed. Duh, you know? But I mean, the truth is, to counter that with, is saying that solar power failed at sunset is like saying that a coal plant failed because it takes a really long time to start up and shut down. You can't just have it whenever you want to have it, you know? So there are two different sides to the story. So yeah, that's all of the stuff that I have to present today. And please ask questions. Feel free to email me. Um, and I can also share this PowerPoint also with you guys if you would find that helpful. But
Hey,
yeah,
thank you, Jenna. Why don't you stop the screen sharing so we can kind of see if people raise their hands? Most people are familiar with how to raise their virtual hands, but let me get started with the questions. As you've pointed out, there's a number of different distributed energy resources, and I'm wondering if you're a third-party aggregator, uh, whether from what you've kind of studied and thought about, would it be advantageous for a third-party aggregator to have uh, a mix of different types of technologies, maybe EVs and solar, and shutting off hot water heaters? Or is it just more practical because of the complexities with technologies and scheduling to just for a third party aggregator to focus in, let's say, just on EVs versus other technologies?
I think that's a great question. Um, yeah, I don't know for sure if like current aggregation companies are just focusing on one thing or if they're trying to capture everything. Um, yeah, they're definitely like EV charging, HVAC, solar are all modeled in very different ways. So that adds complexity to how you're going to bid into the market. It also adds complexity to how you structure your control. Um, and if you want like the most optimal bidding and the most optimal control for that technology, maybe you want to focus on that technology. But um, there's a lot of like ideas and themes that are common across technologies, and that's why we're able to work on so many of them. Um, so I think the goal would definitely to be able to use solar and electric and all these different things in order to get flexibility and also maybe like have the most optimal resources for different services. Um, like electric vehicles might be really good for frequency regulation because they can respond really quickly versus HVAC usually has a little bit of a communication delay and like a control delay. So it might be better suited to like voltage regulation or something like that.
Okay, hey, thank you. Hey, thank you too for the last slides suggesting some things GLREA could do. I think we should encourage all our speakers to do that. That was great that you kind of threw out some ideas. Anybody got a question? Raise your virtual hand.
I want to say I saw in the chat, Mike Buda said, I know that GM Energy are just focusing in on EVs in their research. That's good to know. We also have one of the companies that is involved in this project is GM.
Yeah, go ahead, Doug.
Yeah, I'm curious for everybody, I guess, Jenna, for sure, is um, I've never heard of the concept of aggregators before. Are there like 10 companies in the country or two or none and what kind of equipment would they have? How do they interact with MISO and DTE and the generators? I'm kind of confused as to where they would or do fit in.
A great question. I know of one startup company in Michigan. I think there's one in like the PJM area. There's some in Europe. So I don't really know how widespread they are, but I do know that the ISOs are still working on being fully compliant with the Order 2222, so it's still a work in progress. And then how would an aggregator like actually communicate with MISO? Um, so surface level, like the minimum thing that you would need to have is the ability to use an Excel spreadsheet. That's how the generators submit their bids in the day-ahead market, if they just submit a spreadsheet. Um, but to be able to provide like frequency control, voltage regulation, you need to have really good communication data that can update like, well, even just like every 5 minutes or something like that. Um, and that's pretty much it. So we just get that communication from the market and then we figure out the controls on our end. But there might be more to it. I'm not totally sure. I've never been into the market myself.
So there's going to be quite a bit of cooperation from the different parties. Otherwise, they could kind of shut you out.
Like the like my cell could shut you out, or
Oh yeah, exactly. Or DTE or whoever. They just
oh yeah. If you don't obey hosting capacity limit, then DTE could maybe do something. Now that I don't think there's anything in place where DTE could like shut down an aggregator, but
hmm.
yeah, I see what you mean.
Yeah, go ahead, John.
Well, I don't pretend to be an expert, but I do think that DTE and consumers would have to be involved because, based upon your theory, Jenna, if you get a lot of aggregation of energy from EVs or DERs going to the grid, and there's less of a need to have peaker power plants because there's additional capacity being generated at the distributed level, then DTE would need to know that because they have to plan for every single kind of contingency type situation. Um, so, and I would assume, Doug, that each individual who has an electric car or who's willing to participate, they would have to sign a contract with the aggregator that gives the aggregator the ability to take control of their car or take control of the energy and be able to shift it when they need to,
Hmm.
whenever there is a demand or a peak demand. And so the person at the individual level, they're obviously being compensated. And part of that compensation, I have to believe, is the fact that in certain situations that they may not be able to use their car for that particular moment or whatever because the power is flowing back to the grid. Um, Two other comments. Dale Klein in the chat, he put in another example of an aggregator, Ohm Connect. So folks may want to Google that. But my real question, my real purpose in raising the hand, Jenna, is as you probably know, that both utilities have to file an integrated resource plan this fall, where they have to submit a blueprint of how they plan on generating electricity and providing the capacity that will be needed for all their customers. And it seems to me that your proposal about having an aggregation of DERs would fall into that kind of a planning document. Um, we have a we have a member, his name is Richard Bianchi, who's doing a lot of work on virtual power plants, which is very similar to what you're talking about. I mean, one could maybe argue that what you're suggesting is a particular type of a virtual power plant. Anyway, so we have a call every Tuesday at 11 o'clock. And I mentioned on the call that you were going to be presenting this tonight. And Richard couldn't be on tonight because he had a conflict, but he was going to watch the recording. And I'm going to probably encourage him to contact you after he watches your recording to see whether you guys could compare notes. And because we're going to be intervening in these integrated resource plan cases, we're going to be challenging the utilities on what they propose. If we think we've got better ideas and how we can provide the energy that the utilities need at less costs by, for instance, using your model, then we're interested in pushing that. Now, whether the Public Service Commission would agree to that, I don't know. But the only way to really get this to move is to get the regulators to convince the regulators to do it and because they have the power to enforce it over the utilities, which would then open up the market for aggregators. I'm sure Ohm Connect is operating in states where these programs are allowed to occur, in part because the Public Service Commission in those states have agreed to this program. So I just want to point out the integrated resource plan cases to you and to make sure you're aware of them. That's it. Thank you.
You go ahead, Harvey.
So this whole discussion sort of begs a point as I think about it. What's to keep a utility from setting up what I will choose to call an internal uh, aggregation? So the utility goes out and says, hey, we'll put solar panels on your house or business. And, as part of the deal, you sign up to be an aggregator. You sign your vehicle up to be in our aggregation pool. So they now have their own they become their own aggregator to preclude other people from entering the market. So you've got what I'll call private aggregators, which we'll call Ohm Connect, a private one. But you could also have each utility creating their own aggregation of electric vehicles. Is there any place in the country that we know that that's going down?
I do not know. The flyer that you sent me from Richard Bunky of like the IO Go program, like by Octopus or whatever. It kind of seems like Octopus is something like DTE. I'm not really sure, so like that might be an example of that. But exactly, like there's nothing in the order that says that utilities can't be the aggregators themselves. And that's something that we asked DTE and consumers as part of this project is like, do you guys see yourselves as the or do you see it being like a third party? And so far they're saying we see it as being a third party, but it might maybe someday they might take it up themselves. Um, I'm not sure exactly what it is, but there's something going on in North Carolina, where it's like a energy like co-op or something, and they control the hours in much the same way, locally. But I don't, yeah, I have to read up more on that. But um, yeah,
Go ahead, Dan.
Yeah, this is some of us are in the DTE Weave Grid EV charging program, and that is sort of a more finite charging program where they can control it on like a 5 minute basis while you're plugged in overnight. And if you watch how the charging does, they really do play with the charging a lot. Um, and I believe WeaveGrid does this with a number of utilities, and they give you a small benefit, like a $5 a month discount for joining that. And it's sort of similar to the way they can control your HVAC, but when I've looked at it, I have it on my EV, and it really does do like 10-minute blocks where they sort of make a decision whether or not they're going to charge during that period, and then they make a commitment that your car will be at whatever 80% by the morning.
Yeah, thanks for sharing that. Paul, go ahead.
Um, I'm sitting here and I'm scratching my head. This is kind of a new area to me. So when I plug my car in every night and I come home, what am I doing wrong? Is there a better way to do it? I have a plug-in hybrid and it charges up overnight and I love it during the summertime because pretty much I drive all on electricity and doing that. But this is kind of new to me. So I just got off the bus from Mars. And what is the simplest definition of an aggregator and why is that the key element in this whole discussion, if I may be so bold to learn from?
yeah, that's a good question. Yeah, I don't know, like I don't have an EV myself, but I know like there are different apps you can use to like charge it at the greenest time or like the least cost time based on time of use like and stuff like that. But so the simplest definition of an aggregator would probably be something like in Kaiso, they have a lot of like energy storage resources. Um, and a lot of the times we think of ourselves as an aggregation like as like a virtual battery, and there are specific services that these energy storage resources can provide. Um, but why do aggregation at all? So if you as like a single EV are not allowed to participate in the market. So the ISO set like a minimum like megawatt hour capacity that you have to be able to bid. So it only works if you have enough EV that you can meet that minimum capacity to be able to bid.
So that would be for a large company that's running a fleet of vehicles of EVs. I mean, like Amazon, for example. And what's so it's an advantage to them. But I, as a single plug-in, I plug it in and have not really thought about this before. So this is a bigger uh, area to learn and study about to make it better for everybody. But I only have one car, I plug it in. But if Amazon is running a fleet of 1,000 cars, so that's important to them. And then I'm hearing Dan with regard to Dan, you have an electric vehicle and you have a charger that you're able to adjust so that you at demand times.
Well, WeaveGrid is this company, and they manage it, and they're probably managing thousands of EVs. I don't. I
So
can
you
just
as an individual owner of an EV have joined this Weave Grid and have a charger that reacts to their charge timing.
Uh, yes, but I don't have any. I don't have anything very special. I think it works with all the GM and all the Tesla vehicles.
Oh, okay.
Yeah, it's an interesting discussion and thinking about what might be possible in the future because a lot of us have solar systems, a lot of us have EVs, and I'm imagining sometime in the future, not anytime soon, some third party aggregator comes to me and says, "Hey, I got a deal for you. If you make your EVA available at these times, these days, we'll pay you so much. If you make your solar system or solar power available at this time, hey, we'll pay you more than uh, Consumers Energy will pay you. So
Mm.
you'll be a much better deal to sell your excess power to us than to consumers, because they'll probably always give me a reduced rate. And so, of course, there's a lot of things that would have to be sorted out before anything like that could possibly happen. I mean, one thing I know from the just my casual reading of the FERC order was that FERC order went into play a long time ago, and they're still struggling with how to do this and where to do it. And I believe, right, Jenna, that PJMM, right, is the farthest along, and there's some ISOs that really haven't done much of anything.
Yeah. Yeah, like on that, like explaining that forecast, it's like, yeah, MISO prepared to be fully compliant by 2028 or like 2030, or like something like in the future. Um, Kaiso has some cool things, cool products that like aggregations of DER can provide, but it's not like fully integrated. But yeah, hopefully it's on the horizon.
Yeah, we're just a lot of us are wondering how we're going to get maybe power from our electric vehicle just to use as backup power for our house, which of course is a lot simpler than what we're talking about here. But in that we got a ways to go with that, obviously. And but these things are heading into a brave new world, that's for sure. Other comments, questions?
Well, the one thing I would say, John, is GM has a system right now. If you put in their system, you can use your GM vehicle and their interface to be a backup. It's not quite where I think it net yet needs to be, but that exists. That technology exists now with the right stuff.
And Harvey, is that available to anybody, or is it more like a pilot basis?
No, if you've got a GM vehicle, that
Yeah,
it's got to be bidirectional. But there have been bidirectional vehicles out there for, I think
yeah,
Lyric has been a bidirectional vehicle for a couple
right.
of years, but you need their power shift charger and a home interface unit, and you can do that. It's not as robust as it needs to be in the future to really interface with the right solar system, a central inverter for the house. Uh, and in the future, I think the level 2 charger and the control system for your solar system in the house, the inverter, need to communicate with a CAN bus. And when that happens, then there are going to be these people that are going to come around and still want to sign you up as an aggregator. And that's going to be very healthy. And hopefully, all Jenna's research can be foundational for that.
Yeah, go ahead, John.
Well, my other comment is that, a lot of times, the private sector has great ideas on how to do things based upon research like Jenna is providing. But sometimes it takes the state legislature or the federal government to put the policy in place requiring the utilities to work with the Public Service Commission to establish this policy, which then enables the private sector to move forward because they've got a regulatory framework in place that's encouraging the utilization of these new ideas. And so that's part of the role that GLREA does in the sense of educating legislators. And, we have a real opportunity in 2027, depending upon how the elections go, to be able to, move some of these new ideas forward. When Whitmer got elected, we were able to get a number of new policies enacted, and we've made progress. Now we have another new governor is going to come into place, and there have been some developments in the last 8 years, and this is one of them. So it's another opportunity to try and enact new policies which can, frankly, turn loose the private sector, which is always the best way of going.
Or I see in the chat, excuse me, Mike Booth says that GM Energy, they can predict where 1 in 3 vehicles, EVs, are available for discharge, and that they're all going to be bi-directional, but the equipment to make it work costs about $7,000. But that, to me, sounds less expensive than what people are paying for like natural gas backup generators. So it sounds like the economics will encourage a bunch of folks to look at their EVs as backup power rather than maybe buying a Generac. But uh, time will tell, I guess. Comments or questions? We still
I
got
have
some time here. Go ahead, Jenna.
a bit jumping off. Uh, I think aggregated can just go ahead and do aggregation now, like as soon as like the market is set up for that. Like I don't think DT can prevent them from doing that. I know like if you're like, hey, I'm gonna put in a new solar panel over here and I want to connect it to the distribution grid, then there's like a whole process that you have to go through with DTE. But aggregation doesn't mean like putting on any major new loads of generation. So that was the first thing. And then the second thing though is, yeah, like I'm sure you guys are all aware that you can do bidirectional charging, but you can only do it behind right now. We really do need some policy push to get utilities to get the ball rolling on how do we allow vehicle to grid to happen? How do we redesign our protection system to make this work? Because that's really going to help with flexibility and resilience in the future.
Well, Jenna, with your interaction with the auto industry, so do you think they're real interested in vehicle to grid, uh, or just kind of looking into it?
Yeah, it seems like they're interested. Um, I don't know, the like individual people that I talk to are like really excited about it. I'm not sure exactly what the incentives are, other than it is difficult to design and sell an EV. It's difficult to sell an EV for less than what it took to make it. So like they're not necessarily making profits on EVs right now. So if they can increase the value of the EV to customers in different ways, one of the ways being bidirectional charging, I think they'd be all for it. But yeah.
Go ahead, Harvey.
Yeah, isn't the Weave program that Dan Schechter was talking about, isn't that an aggregator? They're essentially buying flexibility from individual EV owners, and I assume they're selling it to DTE or consumers or something. Or do I not understand that right?
Well, but what Jenna said too, Jenna, tell me if I'm wrong. Uh, when we think in terms of I guess third-party aggregators could sell to a local utility, but there's this whole push to have third-party aggregators sell to the ISOs. So yeah, that's the whole idea of a third-party aggregator selling to MISO, yeah, it's a whole different story than somebody selling to DTE, right, or consumers. Because I guess when you think about it, all of us solar owners are providing power to our utility usually at some point. And so, it's in that sense, the consumer's energy is an aggregator, right? They're taking power from all of us at times when we have excess power. But I think again, third-party aggregators, a lot of times we're talking in terms of large aggregations and uh, providing power into the independent system operator. Go ahead, John.
So, just to pick up on that point, so if aggregators in Michigan collectively pooled together a bunch of power and sold it into the MISO market, then since MISO covers multiple states, so some other state where there's are willing to pay more for that power essentially will travel out of state to this other location rather than staying within Michigan. Do I have that correct? Do I understand that correctly?
Yeah, it's all up to like whatever the physics of the grid is doing. Like you can't tell an electron to go any certain way, but yes, the whole anywhere in the Eastern Interconnect really that virtual power could go. Of course, there's like you have to have the transmission system and transmission lines set up to really make things flow. But yeah, that could benefit voltages in all the way over in Minnesota, depending.
We've got about 8 minutes left. Let's see, any other further comments, questions? Jenna, do you have any parting thoughts you'd like to leave with us?
It's been a pleasure presenting and answering questions. Um, yeah, you guys have my email, so if you have questions, or need a fact check or something, I'm happy to provide it or talk more. Um, yeah, and it's really cool to see that people are excited about this.
Yeah, go ahead, John.
Just another, Dale once again has put another interesting comment in the chat about the fact that Nissan Leaf has had their electric cars have been bi-directional for the last 10 to 15 years. And so it's just interesting that the, the technology is moving forward, it sounds like from reading Dale's thing. It's just a matter of kind of corralling it and then organizing it to work on behalf of the grid and which essentially is on behalf of all the customers that use the grid, homeowners, business, government, whatever. Um, so it's great that you're doing this work, Jenna. We really appreciate it. And we're big supporters and like I said earlier, Richard will take a look at it and he may want to chat with you. So thank you.
And Paul, did you have a comment you wanted to make or question?
Yeah, I was just thinking out loud, learning from everybody today. I just put up a small system that's self-contained at our synagogue, and we use it for an outdoor shelter, and we have a battery storage. And every day it's full up and is not going anywhere because we're not using it. I'm in the process of now redoing security at our synagogue and front entrance, and we're putting in a snow melt system. And since the storage unit gets power every day, I'm trying to figure out a way of how to make it and use it to help the snow melt. And I'm working with our vendor and so forth. But that just brings up another picture. For those that have this power that's sitting there, I mean, is there a way to, I mean, to take advantage of that aggregate storage that we have every day? Every day, these last 3, 4, 5 months, we've had a couple outdoor activities and we've used the power, but it's sitting there. So I'm just thinking about how the system gets bigger and can be used, and I'm just throwing that out for a thought. That's all at the moment. So how could that work, Jenna?
Yeah, it could definitely work. Like I said, we need the grid to, or like utility to be more open to power flowing a different direction. Um, and I know there are definitely read papers where like it's not just EVs, it's like a whole like housing demand with demand and also like batteries go back and forth. So like people have like researched like that kind of system as well and how it can
Hmm.
provide aggregate energy.
Yeah. Yeah. Paul, depending on what you want to do and where you're located, you know, you can feed that back into the grid, but you got to go through interconnection and all the hoopla with DTE or consumers wherever you're located. But I would guess there are probably half the people on the call that maybe are feeding excess power into the grid.
Right. At the moment, one of the issues was it's self-contained, and we just got in under got under the line for the national rebate, and we're finally finishing that all up. But there was a lot of questions during that whole process because they raised the questions: how come we're not attached to the grid, and when it's self-contained, and we had to go through the whole process to get approval to get our rebate. We finally got that done. But I just think in the future, there's so many ways of taking solar energy and expanding it out. I mean, I would say, what happens if a school system would join in and put solar on all of their schools and create this grid of potential energy source to feed back into a system? And I don't know if there's anything like that in the United States or anywhere that's happened at this point. A large owner of buildings who uses electricity takes the initiative and says, okay, we're going to put solar on every one of our buildings so we can feed back into the system and create another source of energy through an aggregator. I don't know if I'm thinking it out right, but there's so much potential.
Well, this is John again. IKEA does that pretty much all over the world. They have solar on their roof out in Plymouth Township or wherever at Canton, I guess it is,
Yeah.
and that's powering their IKEA building. But Marshall and I, we're actually talking with some people about a potential bill, Paul, to literally encourage schools to put solar on their buildings because they tend to be flat roofs. The schools are going to be there for a long time. And right now, the investment tax credit still applies to nonprofits, which includes schools. So they can get 30% of the cost of installing the system back from a check from the IRS. And the idea would be that during the fall and the spring, when school's in session, the solar would power the school and offset whatever electricity they would have to buy from the utility. But during the summer months, when schools typically are not in session, K through 12 in particular, that could feed into the grid and that could potentially be a stream of new revenue for schools. You know,
Absolutely.
and so Marshall and I we developed a memo about this, and we're talking to two legislators, a Republican and Democrat, about trying to come up with a bill that frankly would restore net metering for schools. So rather than when they export power back to the grid and only getting compensated at the distributive generation level, which is about half the retail rate, we want to go back to net metering, and the compensation would be at the retail rate. So that stream of revenue would, in fact, be larger than it otherwise would if it's just at the DG rate. But again, all this goes back to enacting policies into law, because there are fairly strict rules about what is the definition of a utility. And, one of the reasons why Ann Arbor is creating the sustainable energy utility is because they realized that since they are in fact creating a utility, they can do whatever a utility wants and can do, which is just about anything. Whereas if you're not defined as a utility, like a homeowner can't become a utility. They can't put solar on their roof and sell it to a neighborhood business down the road, because that in fact makes you a utility, which is prohibited by state law. And so this all goes back to these are all terrific ideas, the ideas generate faster than the regulations allow them to implement. That's the challenge in a democratic society. But that's why GLREA is so important because we take these amazing ideas from Jenna and we try and put them into the integrated resource plans because we intervene in these rate cases in the front of the Public Service Commission. And then we also try and enact policies through the legislature. And if we ever get a federal government, get a Democratic president, we will engage in trying to enact new policies at the federal level to make them nationwide and not just state by state.
Yeah, that just opens up a lot. Is something I teach in the Detroit Public Schools at Randolph Career Training Education. And to make a long story short, we have a DTE program for lineman repair, but we're incorporating a solar energy element into it. And with Eagle, they have this grant going on, and I passed it on to the principal, and he's passed it up to the upper echelon. I want to talk to you more specifically, John, about this to maybe think about, and I'm just off the cuff, to use Randolph as an example to prove that point about putting solar energy on the building and doing just that in a small scale. I've been actively involved in it right at this moment, trying to generate the interest at the the upper level, to do that at the school.
Well, Paul, just one other comment. Ann Arbor schools have been putting solar on Ann Arbor schools for years.
I know that.
And the head of the guy in Ann Arbor, help me out, John. It's got kind of a funny name, real nice guy. Um, he did a solar story 3 or 4 or 5 years ago about this, but he used to work for Detroit Public Schools and attempted to get more solar on Detroit Public Schools. And he had limited success, and he bolted out to Ann Arbor because they were much more interested in being
Right.
aggressive about doing this.
Okay. Well, that's interesting. I'd like to find out who that was.
Yeah.
Well, hey, Jenna, thank you and for your presentation and also for kind of stimulating an interesting discussion. And next week, we're going to have Ann Arbor come and talk to us about their Solarize program, give us an update on how it's going. So hope to see you all back here next Thursday. Take care. Have a good weekend.
Great job.
Thank you, guys. Good
Night.
night.